Let's have a look at the online version of GeoGebra, the in-browser version. So you can just Google GeoGebra online, but you can also go to this address, so web.geogebra.org. We're going to do some 3D geometry, so I'll click on 3D graphics. We'll get you this view. We're going to look at an example where we determine the angle between the line and a plane. So in order to construct a line, we need a point and a direction vector. So let's start. I'm going to name my point A, and then write equal to, and then left bracket, and we'll get the right bracket right away. And then I'm just going to enter the point 1, x coordinate 1, y coordinate -1, z coordinate 0, and then press enter. And then you see it here. If you don't see it right away, it might be because it's out of range. So then you can just use the scroll wheel to zoom out. You see this, the grading of the axis is changing. We can zoom in, or you can press, if you have a scroll wheel, you can kind of move the coordinate system a little bit towards the center. Okay, so this is a point very close to the origin. The direction vector or vectors in general, you have lowercase letters. So for example, u is equal to, and then 2, 1, 2 in this case. Now you see the vector and the point. Actually, you don't want this later when you have the line. You just need them to construct the line. So I'm going to show you later how to make them invisible. This is just a way of getting the line. So I'm going to start writing line, and then you see all these alternatives. You have a point and you have a direction vector. Point and direction vector. So I'm going to click here, and then the first point is named A, and then I think you have to select everything or delete. It has to be the point, comma, and then the direction vector. Now I'm going to click or type enter. There you have the line. I'm going to click here. You're going to use this a lot. Rotate. Now I can see the line here. Beautiful. I don't need the point anymore. Okay, so I'm just going to go here, and the point disappears. And here, to kind of make it invisible. It's still there, but I don't want to see it here. You can also go right click and then show object, or unclick show object. Now we have a line. I would like to enter the equation of the plane, so you can come up with any name. I'm going to name it pi, and then you type colon, and then I'm going to enter the equation x plus y minus 1 is equal to 0. You can either, let's say if it would be a 3 here, you could either write it like this, or then it would be -3 is equal to 0. Both are just fine. Okay, so you just enter the equation. So equal to 0 in our case. Press enter. And there's our plane. It looks a little bit funny, so let's rotate so we get an idea how it looks like. There we go. There we see the plane. And let's have a look at the plane. Here we get kind of the angle, an idea of the acute angle. Okay. You notice also that it kind of named our line A, and then colon. It did this automatically. It doesn't really matter. So line through A with direction vector U. Okay, so this is our line. Here we have our plane. Now we'd like to find the angle. And here we have many different functions. I'm just going to click angle, and then down here usually gives us some instructions. Select 3 points or 2 lines. So let's see if I can select this line and this plane, and then we here have 45 degrees. You can also see everything that is happening here in the list. Okay, so that's how we found out the acute angle between the line and the plane.